This video is about quadratic regression and this examples of quadratic regression. This first problem says, use quadratic regression to find the best fitting quadratic model. Quadratic regression to find the best fitting quadratic model. We are modeling the data. So our problem says, a huge Tiffany lamp hangs from the top of an elegant stairwell in an old opera house downtown. The base of the shade is 5 feet in diameter. The top is about 3 2/25 inches above the vertex of the parabola shown in the graph. What is the height of the Tiffany lamp? So whenever you have word problems, you really want to read through it and find the information that's the most important. The fact that it's a Tiffany lamp is not important. What is important is that the base of the shade is 5 feet in diameter. 5 feet in diameter. If we look at our graph here, it goes from the origin from 0, 0 to 5, 0. So this right here is 5 feet. 5 feet. Then it says the top is about 3 1/4 inches above the vertex. So it says above the vertex. So if we look, this is about the vertex of our parabola. The parabola is this shape right here going along the Tiffany lamp. So our vertex is right here at the top of the parabola, but that's not the top of the lamp. The top of the lamp is actually above the vertex. So we're actually asking to figure out what this value is. Do you also notice that it says about 3 1/4 inches above the vertex? But in the earlier part, it says 5 feet in diameter. So we know that we're probably going to have to do something with that inches and feet. That is 2 different units, so we're probably going to have to convert something. Then the question asks, what is the height of the Tiffany lamp? So what is the height? This is our question. And the height is the y value. Height is the y because when we figure out height, we always go vertical. So what we need to do, it says use quadratic regression to find the best fitting quadratic model. We don't have the equation here. We don't even have technically the vertex yet because this coordinate right here is not the vertex. See how it's off center? So that means we need to actually find the vertex of our parabola so then we can find the height above the parabola. So we want to find the equation of best fit. So find the equation using regression. So this is our first step. Find equation using regression. Because we have coordinates. We do have our x-intercepts and we do have a third coordinate. So you could actually find this using intercept form. However, I want to show you in the calculator how much quicker this can be. So using a newer calculator, I need to find the equation. So in my L1s, I remember to put my x values. My x values are at 0, at 3, and at 5. My L2s are going to be my y values. So at 0, the y value was 0. At 3, my y value was 3.8 or 3 8/10. And then at 5, my y value was also 0. So I'm going to go to my calculator. I'm going to go to my stat, edit. L1s I'm putting 0, enter, 3, enter, 5, enter. My L2 I'm putting 0, enter, 3 8/10, enter, 0, enter. Then again, going back to knowing how to do this, I press the stat key. I go over to calculate. And I want quadratic regression because this is a parabola, so I press 5. And again, my L1 is in my x's. My y's are my L2, so that's good. Skip over frequency list. And you come down to store regression equation where your cursor is blinking. Now I press the vars, y vars, enter on 1 function, enter on y1, and we want to go down to calculate. This is the equation. Now I'm going to round these to the nearest hundredth, And again, the reason why we did the vars, y-vars, is because this will actually put it into our y equals for us so that we don't actually have to round them in our calculator. This will put the exact equation into our calculator instead of us rounding it. You always want more of an exact answer because rounding will make it worse. So that's why the vars, y-vars is crucial. So our A value was negative 63 hundredths. So negative 0.63, so negative 63 hundredths. Our B value was 3 and 17 hundredths because the 6 makes this 6 round up to a 7, so 3 and 17 hundredths. Then our C value was 0. So the equation of best fit would be y equals negative 63 hundredths x squared plus 3 and 17 hundredths x, and then it'll be plus c, which is 0, so we don't have to put anything for that. So this would be our equation of best fit. The question again is, what is the height of the Tiffany lamp? We still haven't found the height of the Tiffany lamp, so we're not finished. And again, why did we really do this? We just found the equation, we just found the parabola. So if I were to press graph, because my y1 is in there, this is the Tiffany lamp. Now this is a parabola, so the whole point of this is that this part right here does not actually exist in real world. Because this is when the lamp keeps going down, and we know it doesn't go down forever. So this part right here is what we want to focus on. This is your 5 feet in diameter, and then this is our height of the parabola. Now we don't have the actual height of the lamp, so we need to find that. Now it does say that the top is about 3 1/4 inches above the vertex. So what does that mean? It means we really need to find the vertex of our parabola and then go above it. So instead of trying to guess where it's at, we can actually find the vertex from our calculator. So the next step in the problem would be to find the height of the parabola. Because we have the parabola itself, and we can find the height of the parabola, which we do that from the vertex, which, if we remember, the height is going to be our y values. So it's the y value of our vertex. So I'm going to show you how to do that in the calculator again. So instead of trying to do this manually or by hand, algebraically, we're going to use our calculator. So we're going to find the vertex. Now this is a maximum, so we want to go to second, trace, because that's calculate. We want the maximum, number 4. Now it says left bound, so my cursor is blinking on the left of my vertex, so I can press enter. Now it changes to right bound, so we have to go over to the right hand side until it's to the right of the vertex. My cursor is on the right hand side of the vertex. I don't have to make it go too far. It is on the right, so I press enter. I don't want to guess, so I just press enter. This is our vertex. So we have 2.5, comma, 3 and 96 hundredths. So that's our vertex. So I'm going to write that down. We have, the vertex is at 2.5, comma, 3 and 96 hundredths. That's our vertex. So we now have the y value of our vertex, which is 3 and 96 hundredths. So the top is about 3 1/4 inches above that y value. So if I take, I'm going to get out of that, I'm going to take my 3 and 96 hundredths. I'm going to add that 3 and 25 hundredths. I get 7 and 21 hundredths. Now, is that the correct height of our Tiffany lamp? Does this make sense is really the question. We know that these are in feet. These units is 1 foot, 2, 3, 4, 5 feet. So then that means that our y should also be in feet. So this is 1, 2, 3, 4. It doesn't go all the way up to 7. So this height of our Tiffany lamp is actually just a little bit above 4 feet. So why is it that this answer is not accurate? We found our vertex correctly. This is not incorrect, so this is good. But the thing is that this was in feet. So that means we have 5 feet in diameter, but the top is 3 1/4 inches above the vertex. That means that we actually have to convert either our inches to feet or our feet to inches. So our height, I'm going to write a little note down here. Our height is actually 3 96 hundredths feet from our vertex plus our 3 1/4 inches, because that was 3 1/4 inches above the vertex. Because we can see that it's going to be slightly above 4 feet, I'm going to keep my units in feet. So I'm going to convert inches to feet. Now, inches is a smaller unit, but it has a bigger number. So since feet is a bigger unit, it will actually have a smaller number. So to convert this, we take our 3 1/4 inches. And again, so inches is a smaller unit, but it has a bigger number. We want to go to feet. Feet is a bigger unit, so it has a smaller number. So how do we convert inches to feet? We'll actually divide, because we want our number to get smaller. And there are 12 inches in a foot, so we divide by 12. And that'll give us 27 hundredths feet. So 3 1/4 divided by 12 gives us roughly 27 hundredths feet. So now we can actually add our height of our parabola plus our 27 hundredths feet. So 3 96 hundredths feet plus the 27 hundredths feet is equal to 4 23 hundredths feet. So if we look back here, we have 1, 2, 3, 4. And we can see that the height is a little above the 4. So 4 23 hundredths feet does make sense. So we can say that the height of the Tiffany lamp, is approximately, so we do those two squiggles, approximately 4 23 hundredths feet tall. That was our question. What is the height of the Tiffany lamp? So our height of the lamp is 4 23 hundredths feet tall. And we have these, again, these are in feet. And we can see that that height is roughly above 4. So this makes sense. This is our answer of our height. You have to make sure that you read very carefully about what you're trying to find and if there's any conversions in the problem. And you always go back to see, does it make sense? The 3 96 hundredths plus the 3 25 hundredths did not make sense to do, because when we got our answer, it was way above the height of the lamp. So make sure you always look back to see if it makes sense. And again, the reason why we want to do the vars, y-vars, is to put our equation into our y1 so we can easily graph it and find our vertex. On this next example, it says use quadratic regression to find the best fitting quadratic model and make predictions. Regression is great for making predictions because you're finding the equation of best fit. However, the predictions are in fact that. They're a prediction. They are not exact answers. So it says youth football. The following table shows the number of participants Y in the local youth program from 2000 to 2005. Assume that T is the number of years since 2000. So if you notice in our table, it says year T is 0, 1, 2, 3, 4, 5. It doesn't say 2000. Whenever you're dealing with years, you never actually want to use the full year. You want to figure out what your starting year is, and then that's our 0 value. Then every year after that, you just count up. So 2000 is our year 0. So this is technically year 2000. Then this is year 2001, 2002, 2003, 2004, 2005. We don't actually put the full year in there because then the equations get very wonky. So we just use 0, 1, 2, 3, 4, 5. Then we have the participants, our Y values, of 24, 28, 33, 41, 54, and 74. So we can plug our values in here. Again, we want to say since 2000. Anytime it says since something, that tells you that's your 0 year. That's your 0. That's what we always want to have. So in our chart over here, which we're going to put in our calculator, I'm going to put my x's in L1. So it says the table Y in the local youth program, and T is number of years. So T is your X values. So we have 0, 1, 2, 3, 4, and 5. And then our L2s, we're going to put our Y values, our participants, which are at 24, 28, 33, 41, 54, and 74. Now, it does get kind of cramped in here if you're writing them down, but when we're putting them into our calculator, it makes it a little bit easier. So I'm going to go and take my stat, edit. Now, I still have the problem from the last problem, so I'm going to come in here and clear these out. Do not press delete, because if you press delete, that goes into L1 and then becomes L3. It'll delete the entire list. You don't want to do that. You need to press clear and then press enter, and it clears that entire list. You'll go over to L1 and go up to the actual L1. You'll press clear, enter, and that clears the entire list. So now we can go back in here and put our L1 as 0, enter, 1, enter, 2, 3, 4, 5. Go over to L2, put in the 24, enter, 28, 33, 41, 54, 74. And as you can see, we still have our list lined up. So that means that we should not have any mismatched. We still want to find using the model. It says using the model. So we have to find the model. So always our first step is going to be to find the equation using regression. Find equation using regression. So we're almost there. So all we have to do, we have our list in here. We'll go to stat, calc. This again is a quadratic regression, so we're going to press number 5. And again, the newer calculators, I have to go down to store regression equation. I have L1 and L2. Skip over frequency list. I go to store regression equation. I press the vars button. Vars. Go over to y vars. Enter on function. Enter on y1. I go down to calculate. Now that I have L1, L2, y1, I can go to calculate. Press enter. Here's our equation. So our A value is 2. So come up here and put 2. Our B value is negative 4/10, negative 0.4, negative 4/10. And our C value is 25. So I can write the equation underneath here. I can plug it into the A, x squared, bx, and c. So I have y equals 2x squared minus 4/10 x plus 25. We now have the equation. So the question says, using the model, how many participants are projected for 2008? How many participants? Participants are your y value, so we need to find a y value for 2008. That means that we have our time. We don't actually plug in 2008. This is really 8 years after 2000. So instead of putting 2008, we actually just talk about 8. T, the time it's after from 2000, T would actually be equal to 8. Therefore, our X value will be 8. X equals 8. There's 2 ways to do this. You can actually plug in the X value into your equation. But again, this is also could be a rounded equation. So you got to be very careful about that. You can plug in 8 into your X values and solve. However, because we did the vars, y vars, this equation, the exact equation, the non-rounded equation, is inside of our calculator still. So instead of actually plugging it in ourselves, it's already in our calculator. So what you actually want to do, since it's already in our y1, we can look at the table when x is equal to 8. Now, to get to the table, you'll press second graph. So I'm getting my calculator back. So I still have the equation right here. I'm going to press the second. So if I press y equals real quick, this equation is in there. If I press the graph, can't really see anything because if you notice it's opening up and the y-intercept is at positive 25. So I can press zoom 3 for out and I press enter and see what happens. There's my parabola. Okay. So I'm going to go back to zoom 6 just because I want it to the normal screen. But that doesn't help us. We want to look at the table. So we press second graph because it says table up here. Now we want to go where x is equal to 8. Now we can just scroll down. We can scroll down to when x is equal to 8 and get our value. However, I want to show you another way of doing that. If it said find when you were in 2053, you can actually, instead of scrolling forever, you can actually set your table to a very specific x value. So it says table set right here. We want to set our table. So we press second table set. We can start our table at a very specific value. So if I want to start at 8, I can say I want to start at 8. This delta symbol, it says delta table. This is the change in your table. What this means is that these are counting by ones. Every x value is going by ones. You can always change that if you have decimals. You can always have it going by a half or a quarter. But I'm going to keep it at 1 right now. But I want to start my table at 8. Once my table is started at 8, I can actually go back to second table. And now my 8 is on my x. Again, I could have scrolled easily going up and down and gotten the same answer. But here's the y value, which is the participants. So in our answer, this is going to be an approximate because we know it's not an exact answer because it is a prediction. It is a prediction. So the year was supposed to be 2008, so we're going to write a complete sentence. In 2008, the number of participants predicted, we can't say just is, it's predicted, is about, so that's around or approximately, is about, so we go back to our y, so 149 and 8/10. So that's going to be, we're going to round to the nearest whole person because you can't have part of a person. So we're going to say is about 150 because we're going to round up. So it's about 150 participants. So again, I'm going to write that little note about the 149 and 8/10. 149 and 8/10. We're going to round up for a whole person. So again, we look back at the question, using the model, how many participants are projected or predicted for 2008? So in 2008, the number of participants predicted is about 150. This is how you actually predict values for anything. After you have the equation, you can predict values for anything. Again, it is a prediction, so it's not going to be 100% accurate, but it is a good chance to see, am I on the right track? And because our graph, when we look back at our graph, even though it was zoomed out, you can see that this will keep going up. So we know that in 2008, it will keep going up in value.